Alright guys, so we're talking about graphs of equations. We're going to start pretty simple and we're going to work to the more complex. The more complex will be in the second set of notes. We're going to do examples 1 through 4 here and stay pretty basic. Now, we're going to do this pretty quick, so I need on Monday for you to do 1 and 2 in class, and on Tuesday to do 3, 4, and 5. Don't overcomplicate these. Insert 0 for x and solve, then insert 0 for y and solve. Okay, don't try to write y equals mx plus b. Don't overcomplicate it. All at once is the x and y intercepts for each. Okay. Example right here, we're trying to determine if each one of these points, a and b, lie on the graph y equals 10x minus 7. Don't overcomplicate it. Okay, so first part, y 13 equals 10x, which is going to be 2, minus 7. If they equal each other, a is true. Okay, 10 times 2 is 20. 20 minus 7, 13 equals 13. A is true. Now we check b. Okay, so it's negative 3 equals, that was my y, 10, insert negative 1 for x, minus 7. Negative 3 equals negative 10 minus 7. A negative plus a negative, add the numbers together and keep the sign, is a negative 17. This does not work. This is false for b. Okay? Pretty simple. Don't overcomplicate it. Scoot so we could see example number 2. Alright, example number 2, we're going to sketch the graph of y equals 7 minus 3x. The simplest thing to do here is to make an input-output chart. So that's what we're going to do. We're going to say x is on top, y is on bottom. We really only need 2 inputs. Okay, we want to know where x is 0 and what that's equal to, and then we want to know where y is 0 and what that's equal to. Alright, so here's how I'm going to do this. I'm going to take 0 and plug it in for x. Y is 7. Okay, if you're confused as how I did that, it was 7 minus 3 times 0 equals 7 for y. Now I'm going to do the exact same thing, but I'm going to plug in 0 for y. Alright, 0 for y means that 0 equals 7 minus 3x. Move the 7 over and divide by 3. Now when you move the 7 over, that's a negative 7 equals negative 3x. Divide by negative 3 for each. So in this case, x equals 7 thirds positive. So let's write that down, 7 thirds. Now, can we graph 7 thirds perfect on the line? Probably not, but we can sure label it. So my y-intercept of 7, we'll put it right here, and I'm going to label it as 0x, 7y. Then I'm going to come over here to my x-intercept, and I'm going to go out, and let's say about right there. Okay, and from there I'm going to call that 0, 7 thirds. Now, connect my line between those 2 points, and we're going to assume that everything that lies on that line is true because our intercepts are true. Boom, boom. Perfect line? Probably not, but it'll work for us. Okay? So now we're going to look at example number 3, a quadratic equation rather than a linear equation, or a polynomial. Okay? So, when you're doing a polynomial, what you want to do is you want to find the intercept first. Okay? Well, because we have no, I'm sorry, not the intercepts, we want to find the vertices, or the vertex first. This one's pretty easy because my vertex is going to be at negative 2. Without there being x squared plus or minus an x, and then minus the constant, my vertex is set alone right there. So my vertex in this case winds up being 0 with -2. Now once you do that, once you know your vertex, you really just want to pick a number on either side of the vertex. So I'm going to go with -1 and, I don't know, +1. If you want to go more, you can. For us, really, this is all we need as long as the vertex is included. If you don't include the vertex, you're going to wind up needing a whole lot more points. So -1 goes in, -1 squared minus 2 winds up being -1 for the answer. Same thing with +1. +1 squared minus 2 winds up equaling -1. So I'm going to come down here and I'm going to put right there and call it my vertex 0, -2. Then I'm going to come over and go to a -1, -1. I'll call it right about there. And then to +1, -1. And label both of those -1, -1, +1, -1. So our graph is growing something like this. Is that perfect? Probably not. But we get the general idea. Okay? Again, do not overcomplicate. Alright, my other one's on the floor. Let me grab it real quick. So example number 4, finding x and y intercepts with larger polynomials. So, first thing I need to do before I worry about finding my x and y points, I've got to solve for my different x-intercepts because I'm going to have several of them. Okay? Here's how we're going to do this. We're going to take x cubed minus 4x. First thing I'm going to do is set this equal to 0. And then I'm going to say, you know what, I can take an x out. And I'm left with x squared minus 4. So now I'm going to take x, say x equals 0 for my factor. And then I'm going to say that x squared minus 4 equals 0. So that x squared equals 4, which means x equals the square root of 4 plus or minus. Square root of 4 plus or minus means that we've got -2 and +2. So my different x-intercepts. -2, +2. Let's go plot these. 0, -2, +2. And we're going to go -2, 0 here. Right here, we're just going to, we'll leave that one alone. That's pretty simple. 0, 0, origin. We know that one. Then we're going to go 2, 0 here. So when I'm looking at what points to plot, okay? And just a little bit more space. Here we go. So my first point that I would have plotted would be -2, and I'm going to get 0. Okay, somewhere between this we need to plot another point. So if 0 is going to be in our middle, then let's use -1 here. Okay, outside point 2, and we get 0, 0. And in between we need to plot a +1 now. And all we're going to do is put that into the graph. So -1 cubed minus 4 times -1 winds up giving me, what is that? -1 plus 4, which is a +3. +1 on the other side. I've got +1 cubed minus 4 times 1 gives me 1 minus 4, which gives me -3. So I'm going to go plot these points real quick. At -1x, we're +3. That's caught right there. Okay. So -1, 3. And then at the exact opposite, I'm positive 1, negative 3. Okay? Just like so. Now, if we look at this line, we're going up, we're coming down, then we catch it, we go back up. Alright. By plotting our relative maximum and a relative minimum, we're able to graph this equation. Okay? Again, we didn't use a whole lot of super hard math right here. We just used associative property rule from here to here, and then set them equal to 0 and worked through. Alright, so your hard question, your HOQ question, I need you to describe to me everything that you know about graphing a circle. That will be the last example for this section we go over. But I need to know what you know about it before we get to it. Okay? So as much as you can write about it, write down. See you in class Monday.